there are many more advanced learning algorithms than the regression-based approach. And they generally attempt to directly optimize a retrieval measure, like a map or NDCG. Note that the optimization objective function that we have seen on the previous slide is not directly related to a retrieval measure. Right? By maximizing the prediction of 1 or 0, we don't necessarily optimize the ranking of those documents. One can imagine that while our prediction may not be too bad, let's say both are around 0.5, so it's kind of in the middle of 0 and 1 for the two documents. But the ranking can be wrong, so we might have got a larger value for D2 and then D1. So that won't be good from retrieval perspective, even though by likelihood function, it's not bad. In contrast, we might have another case where we predict the values all around 0.9, let's say, and by the objective function, the error would be larger. But if we can get the order of the two documents correct, that's actually a better result. So these new, more advanced approaches will try to correct that problem. Of course, then the challenge is that the optimization problem will be harder to solve, and then researchers have proposed many solutions to the problem. And you can read more the reference at the end to know more about these approaches. Now, these learning to rank approaches are actually general, so they can also be applied to many other ranking problems, not just the retrieval problem. So here I list some, for example, recommender systems, computational advertising, or summarization. And there are many others that you can probably encounter in your applications. To summarize this lecture, we have talked about using machine learning to combine multiple features to improve ranking results. Actually, the use of machine learning in information retrieval has started since many decades ago. So, for example, the Rockwell feedback approach that we talked about earlier was a machine learning approach applied to do relevance feedback. But the most recent use of machine learning has been driven by some changes in the environment of applications of retrieval systems. First, it's mostly driven by the availability of a lot of training data in the form of click-throughs. Such data weren't available before, so the data can provide a lot of useful knowledge about relevance, and machine learning methods can be applied to leverage this. Secondly, it's also driven by the need for combining many features. This is not only just because there are more features available on the web that can be naturally used to improve scoring. It's also because by combining them, we can improve the robustness of ranking. So this is designed for combating spams. Modern search engines all use some kind of machine learning techniques to combine many features to optimize ranking. And this is a major feature of these commercial engines such as Google or Bing. The topic of learning to rank is still an active research topic in the community, and so you can expect to see new results being developed in the next few years, perhaps. Here are some additional readings that can give you more information about how learning to rank works, and also some advanced methods.